This is GATE 2016 set 2 electrical question number 28. Let x1t, the Fourier transform, be x1 omega and Fourier transform of x2t is x2 omega be the two signals whose Fourier transforms are shown in this figure. Now x1 in time domain and x2 in time domain are multiplied and the signal is passed through the LTI system having impulse response h of t equal to e to the power minus 2 modulus of t and the output is y of t. Now for the system shown above, the minimum sampling rate required to sample yt so that yt can be uniquely constructed from its samples is being asked. 4 options are given. For NPTEL reference, you can refer to lecture Fourier transform, multiplication and convolution property of the NPTEL course Signals and Systems by Professor Kushal Shah, Department of Electrical Engineering, ISAR Bhopal. Coming to the useful data, the Fourier transform of e to the power minus a modulus of t equal to 2 into a divided by a square plus omega square. The Fourier transform of multiplication of x1t into x2t is 1 by 2 pi into x1 omega convolution x2 omega, where x omega is the Fourier transform of x of t. Now x1t convolution x2t, if we perform the Fourier transform of this time domain signal, then it will come out to be x1 omega into x2 omega. According to convolution theorem, if x1 omega and x2 omega are band limited signals having bandwidth a b1 and b2, then bandwidth of x1 omega convolution x2 omega is b1 plus b2. If the bandwidth of x1t and x2t, those are band limited signals, are b1 and b2, then if you perform the convolution of x1t convolution x2t, then it is minimum of b1 comma b2, because if convolution is in time domain, then multiplication in frequency domain, and in frequency domain the omegas will get multiplied, and whichever will have the least omega, that will be the bandwidth of the overall convoluted signal. Other terms will become 0. So the bandwidth will be minimum of b1 comma b2 for time domain convolution, and if it is in frequency domain convolution, the bandwidth will be equal to b1 plus b2. Now coming to the solution, these are the two signals x1 omega and x2 omega given having bandwidth b1 and b2. Now in the question, these two signals x1t and x2t are multiplied and the overall time domain signal is passed to the LTI system having impulse response ht equal to yt. Now if this is x of t, then yt is given by xt convolution ht. Now yt therefore equal to xt is x1t into x2 of t convolution of h of t. H of t is given to be e to the power minus 2 modulus of t, and this is x1t into x2t. Now convolution. So if we perform the Fourier transform of y of t, then we will get y of omega equal to, now consider this as one signal and this as another signal. These two signals are convoluted in time domain. Now when we perform the Fourier transform, then two time domain convoluted signals will become as per the property shown here. If two time domain convoluted signals are performed with Fourier transform, then the resultant frequency domain signals will be multiplied. So this will be x1 omega convolution with x2 omega, because these time domain signals are multiplied together, so multiplication will become convolution along with a 1 by 2 pi sign. Multiplication will be convolution along with a 1 by 2 pi sign as per property 2. So 1 by 2 pi into this, and convolution will become multiplication, and no 1 by 2 pi term will come. Convolution will become multiplication as per property 3. So this convolution term in time domain will become multiplication, and we need to find out e to the power minus 2 modulus of t, this Fourier transform. So this Fourier transform is given by property 1, e to the power minus a modulus t. The Fourier transform of this time domain signal is 2a by a square plus omega square. So where this a is 2, so 2 into 2 divided by a square plus omega square So this is 4 by 4 plus omega square. Y of omega is given by 1 by 2 pi x1 omega convolution x2 omega into 4 by 4 plus omega square. x1 and x2 are two band limited signals in frequency domain. So when in frequency domain the convolution of these two signals are performed, then the bandwidth of the equivalent signal after convolution is the summation of the individual bandwidths. So this signal have bandwidth B1 plus B2. Now again with this signal, this 4 by 4 plus omega square signal is multiplied. So consider this as one signal now and this as another signal. So when these two signals are multiplied in frequency domain, so convolution in time domain means multiplication in frequency domain, so minimum of the bandwidth will come. So now bandwidth of y of omega equal to minimum of B1 plus B2 and the bandwidth of this signal. Now this signal is not a band limited signal because it is existing for all values of omega, hence its bandwidth is infinity. Now you need to find the minimum of these two to find the actual bandwidth of y of omega, which is equal to B1 plus B2, because B1 is definite, B2 is definite, B1 plus B2 is definite. So minimum of B1 plus B2 comma infinity will become B1 plus B2. So the bandwidth of y of omega is B1 plus B2. Now it is asking minimum sampling rate required to sample yt such that yt can be reconstructed from its samples. Now the bandwidth of yt is B1 plus B2. Now as per Nyquist criteria, the sampling rate, that is the sampling frequency, should be 2 times the maximum frequency of the signal. Now since the bandwidth is B1 plus B2, the maximum frequency possible is B1 plus B2 and the sampling should be done at twice the maximum frequency. This should be the sampling rate or the sampling frequency, maximum frequency of ys. Now maximum frequency of ys is B1 plus B2, so sampling frequency is 2 times B1 plus B2 as per Nyquist criteria. So the answer is 2 times B1 plus B2. Option B is the correct option. Thank you.